Hi, my name is Pavel. In this video I will show you how to increase the speed of KNN classifiers. Say that for this free class problem we want to build a classifier that is both good and fast in execution. We first build a simple classifier such as nearest mean and test its performance on a separate test set with 10,000 samples. On this large test set, it yields 20% error and executes in less than 5 milliseconds. Linear separation is clearly not good enough, and that's why we move to the nearest neighbor classifier. The first nearest neighbor, trained on all 2000 training examples, improves the error to 10%. But its execution is much slower, it's almost 200 milliseconds. It is also not robust in the area of overlap, and that's why we need to move to higher k. For k equal 10, the performance improves, but the execution time now exceeds 300 milliseconds. We have a clear trade-off between error and execution speed. But how can we speed up KNN? One way is by carefully reducing the amount of KNN prototypes, for example using PRSD Studio sdkmeans command. sdkmeans runs k-means clustering for each of the classes and returns first nearest neighbor classifier with cluster centers used as prototypes. Requesting 100 clusters per class, we receive the first nearest neighbor which provides similarly high performance, but runs only in 26 milliseconds. To find the right trade-off between error and speed, we build a set of sdkmeans classifiers, decreasing the number of clusters from 100 to 1. These solutions are denoted by red markers. Note that the fastest sdkmeans classifiers provide large speed increase at the highest performance level. In our example, the classifier with the best trade-off is 20 times faster than the full 10 nearest neighbor. The lesson learned: with PRSD Studio, KNN classifiers can be both accurate and fast.